Hello everyone. In this session, we are going to discuss about the programmer defined data types. So till now, we have used many of the Python built-in data types, such as numbers, strings, list, tuple, dictionary, etc. So those all were defined by the Python itself. So now we are going to learn how to define our own new data types. So for example, we want to create a new data type called as point that represents a point in two-dimensional space. So in mathematical notation, points are often written in parentheses with a comma separating the coordinates. For example, 0, 0 represents the origin and x, y represents the point x units to the right and y units up from the origin. So for example, if this is the coordinate system x and y, so this is our origin, that is 0, 0. Similarly, a point can be represented with x and y values. So here x represents the x units from the origin toward right. Similarly, y represents top towards y from the origin. So now there are several ways of doing this in Python. The first way is to store the coordinates separately in two variables x and y. So for example, I can store like this: x equals to say 10, then y equals to 20. So just print the value of x and I will print the value of y. You can check the type of x here. It is int. Similarly, check the type of y. It is also int. So in the first way, we are storing the values in two separate variables of integer data type. Again, int is a Python built-in data type. Second way is to store the coordinates as the elements in a list or a tuple. So for example, I will store point P equals to 2, 3. Now when I print the value of P, it returns me 2 by 2, 3. Just check the type of P. So it is tuple. The second way is also using the built-in data types. Third way is to create a new type, our own data type called as points as objects, represents the points as object. And a programmer defined data type is also called as a class. So here we can see here I will write in class definition: class point colon enter. So this represents point in two-dimensional space. So this is the syntax for creating the classes: class point. So this point is a class name or also a header, and this is the after colon with indentation. This is the body of the class. So here we can put up our data and methods. So now class point is created. Now I will create one object of this class point. Box, sorry, blank equals to point. Just check here. So now blank is an instance of a class point or an object of class point. Whenever you just print an instance, it is going to return you the class to which it belongs, that is point, and to the address it is referring. This is the address to which blank is pointing. OX represents the hexa values. Creating a new object is called as instantiation, and the object is an instance of a class. And also, whenever you print an instance, Python tells you to which class it belongs and where it is stored in memory. You can observe here it belongs to the class point and it points to this memory. Now suppose I want to assign the values to an instance using a dot notation. For example, blank dot y I will give as 4. So the named elements of an instance, that is x and y, are known as attributes. So now you can read the attributes values the same way using the dot notation, that is blank dot x value is 3, blank dot y blank dot y value is 4. So the expression blank dot x means that go to the object blank is referring and get the value of x. Similarly, we can also perform operations such as x equals to blank dot x. Here we can observe the difference. Left hand side x is a variable, whereas right hand side x is an attribute of blank. So here we can print the value of variable x is 3. So there should be no confusion among the left hand side variable x and the right hand side attribute x. The same concept is defined here in using object diagram. You can see here class is point, object is blank, is pointing to the attribute x and attribute y. We can also use the dot notation in any part of the expression. Suppose if I want to find the distance, right, which is represented by the equation root square root of x square plus y square. So now for that there is a built-in function sqrt given by the Python in the library math. So I should import that library import math. Now to find the distance equals to math.sqrt of x square, that is a blank dot x square. I can use exponential operator, that is double star 2 plus blank dot y double star 2. Now I will just print the value of that distance. You get 5. So it means that we can use the dot notation in any part of the expression also. And we can also pass an instance to the function call. So now I will just redefine my class here. I will write one function or definition to print the point. Print p, print point, which takes a point or as a instance as a parameter p. You can see here I am passing an instance to an function. So now I have to print that point, that is print p dot x. Similarly print p dot y. Now you can see here p is the instance. So I'll just execute this. Now I will call the function. Class point is I'll just re-execute this here. So point is executed, then I will blank equals to point. I will re-execute this. So now again blank dot x equals to 4. Similarly blank dot y equal to 6. Then I will call that function blank dot function name is print point. Execute this. So we got the answer 4 and 6. So we can pass the instance also to a function. In Python, we can use the instance of one class as an attributes to the another class. Say suppose I want to create a class. Rectangle, and then I want to use the attributes such as width, height and corner. So now corner is an instance of a type point. Width and height are again integer. So I just create this class. Now I want to represent a rectangle, so we can instantiate a rectangle object and assign the values to the attributes. Now I will instantiate as box. box equals to rectangle. Now box is just whenever you type an instance, it should return you the class to which it belongs to and the address pointed by it. So you can see here it is of belongs to the class rectangle and it is pointing to this particular address. Now I will assign the values of the attributes. So box dot width equals to 100. Similarly, box dot height is 50. So one more attribute is remaining, that is corner. It tells you the point at which the rectangle originates. Right. So now corner is a type point. So first I have to create box dot corner equals to point. So I am making this attribute corner of type point. Then assign the values of x and y. Box dot corner dot x equal to 0, x coordinate is 0. Similarly, box dot corner dot y equal to 0. So here we are saying that our rectangle is originating at the origin. So you can just see here, this is the x and y coordinate, width and height 100, 50, and it originates from 0, 0. So this is the pictorial representation of the attributes values assigned here. So now box dot corner dot x refers to that go to the object the box is referring, and then go to the attribute named corner, and again it is pointing to some object. From this go to x and take the values. Once I execute this, I can just print the values. Print box dot width. Similarly print box dot corner dot x or y. Now we'll study how a function can return the instances. So the functions can return instances also. Now suppose for this particular rectangle, I want to return the center of this rectangle. So the center will be again a point. Will be again a point which is represented by the coordinates x and y. Now the center of this will be now 100 by 2, that is 50. 50 by 2 is 25. So this point I have to return. Since it is originating from origin, it doesn't make difference. Suppose if the instead of origin it was originating at 5, 3, then it would be 5 plus 100 by 2. Similarly 3 plus 50 by 2. So now we'll write one function to find the center. So that one definition, find center. Now this is taking a rectangle as a parameter. Then I have to return a point. First I have to create that point. P equals to point, then P dot x will be rectangle dot corner dot x plus rectangle dot width by 2. Similarly, P dot y will be rectangle dot corner dot y plus rectangle dot height by 2. Then I have to return this point P. Just check here. Now I'm going to call the function, say the function find center, and I will store it in one variable center. Say center equals to find center, and I have already created the rectangular object, that is box. Just execute this, print the value of center. Print now center. It is just giving center. It is just giving that it belongs to point class, and it is pointing this address. To check the values, center dot x 50. Similarly, center dot y is 25. You can see here 50, 25.